So quick announcement is that the exam grade for exam 3, I have looked over your exams. So uh, for some reason some of the answers, the system won't recognize it, so I manually grade the questions. So many of you get a boost in the grade. That is the main reason. Also, I gave some partial credit for some answers that I think that is, like close enough. So yeah. Today will be the last lecture. Um, on Thursday would be the review, and next Tuesday would be the last exam. And yeah, and then next Thursday would be the review for the whole class, and that would be the last class for the day, for the whole semester. Also, the exam would be on, I mean, the final exam is next Friday from 11 to 1. Friday is from 11 a.m. to 1 p.m. Right? Okay. So today we'll be covering binomials and binomial theorems. So let's do some review. And what we did here before is that we make sense of the sigma notation. Summing up, the sequences can be reduced to a sigma notation. And also, what is factorial? Factorial means you have n times 1 less than n times 2 less than n all the way to 1. Product of these n numbers is called factorials. And of course, we will need both of them for today's lecture. Lecture. So for example, 1 plus 4 plus 7 plus all the way to 25, right? In sigma notation is that we represent 1 as a 1. Okay, then 1, 4, 7 all the way to 25, how many numbers are there? Is that we count how many common differences are there, because this is a arithmetic sequence, right? So the common difference is 3. So from 1 to 25, the difference is 24, which is 8 numbers of 3. So there are 8 numbers of common differences. So the total number of numbers are 9, one more than that. And how to represent AI, right? The general term is that for example, like A2 right, is 4, which means is there are one numbers of common difference, which is 3. So 3 times 1 plus 1. So for AI, the ith number, you have I minus 1 number of common difference, which is 3, added to the first number 1. So simplify this, you get 3i minus 3 plus 1, so 3i minus 2. Okay, so this is how we rewrite this sum into sigma notation. Okay, so the first thing we will be covering today is called binomial. Denoted as nk, right? What does it mean is that this represents the number of solutions when choosing k. Right? I use different color. K items from a set of n items where order doesn't matter. How do we mean by choosing k items from a set of n items? So for example, if you have, let's say, um, mm, for example, if you have right, right, 5 apples, right, and you want to select 2 of them, right? So for example, if you want to give some 2 of them to other people, so uh, what are the total possible outcome of the choosing the apple? So if we number these 5 apples, 1, 2, 3, 4, 5, right? We can the total number of possible solution of picking up 2 of them right? So let's see. The first way is the first 2, like 1, 2, or you can pick 1, 3, or you can pick 1, 4, right? Because the order doesn't matter. Picking up 1, 2 is the same as picking up 2 and 1. So the order doesn't matter. So 1, 2, 1, 3, 1, 5, or 2, 3, 2, 4, 2, 5, or 3, 4, 3, 5, or 4, 5. And there are no other ways without going into repetitions, right? You run into solution that we already covered before. So the total number of them are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the total number of solution are 10 of them. Okay. So this is how we, calculate, I mean, uh, define the binomial nk. And as you can see, is as the number goes larger and larger, this, counting method doesn't work anymore. It takes forever for you to, like, for example, to calculate, let's say, 10, 3. Right? So what is fortunately, the we have a formula for calculating binomial nk. It's equals to n factorial divided by k factorial times n minus k factorial. Okay, so come back to our previous example. Okay. 5, 2 is equal to 5 factorial divided by 2 factorial times 3 factorial. Okay, by the formula. So 5 factorial is equal to 7. No, it's equal to 600. 2 factorial is 2. 3 factorial is 6. No, makes sense. 5 factorial is 112. So 112 divided by 2 times 6, which is 112. 120 divided by 12, which is 10. This is exactly the same as the answer from the counting method. Okay. So let's do some exercise. Evaluate the following binomials. let's go over this. Right, 6 2 by formula is 6 factorial divided by 2 factorial times 4 factorial, which is 720 divided by 2 times 4 factorial is 24, which is 15. Number 2, 0 is 4 factorial divided by 0 factorial times 4 factorial. Well, 0 factorial by convention is 1. 4 factorial divided by 4 factorial, you should get back 1. Right. A3 is a factorial divided by 3 factorial, 5 factorial, and you should get this one a little bit hard. 56. And lastly, 5 is 5 factorial divided by 0 factorial times 5 factorial. Again, 0 factorial is 1, so you should get 1 as your final answer. Any questions? Okay. So if you have, binomial, so the last thing to cover is the Pascal's identity. Okay. Which says if you have n plus 1 of k is equal to nk plus nk plus 1. There are two ways of proving this. One way is using factorial and then simplify. Another way to of proving this is you can view, n plus 1k as picking k items from n plus 1 items, right? The total solutions of the picking k items from n plus 1 items. Right? So to pick k items from these n plus 1 items, right? So 2, 3, and n plus 1, right? So there are two kinds of situation, right? You can, sorry, this is this one. Right? The first scenario is that these k items include the last item. That means the first k minus 1 items comes from the first n items, because you pick the last one. That means you secure the k spots. So that means you have k minus 1 items from the previous n. Right? So that means that is exactly the same as choosing k minus 1 items from n. So that is the binomial n k minus 1. Right? So this is choosing the n plus 1 item. All right. Another scenario is that you don't choose the last item. That means you choose the all k items from the previous n items. Right? They all come from the previous n, because you didn't pick the last one. So This is not choosing the n plus 1 item. Right? So there are only two kind of scenario, right? Either you have the last item or you don't have the last item. So you run out of scenario. So there are only two kind of scenario, and you add them up, and that is the total solution of picking k items from n plus 1 items. So that is the Pascal identity. So one way of using it is, for example, evaluate this. So using Pascal's identity, you can simplify the first binomial. This becomes k plus 1, 3 plus k plus 1, 2. And then you can use the Pascal identity again. K plus 1, 3 is equal to k3 plus k2. K plus 1, 2 can also, using Pascal identity again is equal to k2 plus k1. Right? And there is a minus k3 here. And of course, the k3 is gone. So you have k2 and k1. And k2 is equal to k factorial divided by k minus 2 factorial times 2 factorial. Right? So let's simplify this. Right? K factorial is k times k minus 1 all the way to 1. K minus 2 factorial is starting from k minus 2 all the way to 1. And then there's a 2 factorial. So when you compare k factorial to k minus 2 factorial, right, they have 1, this common factor. They have 2, they have 3, they have common factors all the way until k minus 2. So everything before k minus 2, including k minus 2, is gone, right? Because they happen in both numerator and denominator. They can be cancelled. So the only surviving term is k and k minus 1 divided by 2. So that is the k2. Right? As for k1, you have k factorial divided by k minus 1 factorial times 1 factorial. And again, when you compare k factorial and k minus 1 factorial, all the way, all the factors from 1, 2, 3, all the way to k minus 1 happen in both numerator and denominator. So they can be canceled out. The only surviving term is k. So it's k on the numerator. And 1 factorial is 1. So k divided by 1 is k. So the solution for this thing would be equals to well, 2 of k2. So 2 times k minus 1 divided by 2 is k minus 1 plus k1, which is k. So k squared minus k plus k, so you should get k squared as your final answer. Okay. So that is Pascal's identity. Okay. And there is another identity is nk is equal to n of n minus k. Why is that? Is that, for example, you have n items. 1, 2, 3, all the way to n minus 1 and n, right? When you pick k items out of this n, the list of n items, what you have left are n minus k items. So, for example, if you pick k items out, you have left with n minus k items. Right? So, which means every time you pick k items, you're also picking up n minus k items. Right? These two happens concurrently. So the total number of picking k items is the same as the total number of picking n minus k items, right? Because there was one-to-one correspondence. So they must be equal, right? Algebraically, if you use factorial, what is nk? Is n factorial divided by k factorial times n minus k factorial. Okay. And what is n? N minus k is n factorial, n minus k factorial divided by n minus k factorial. That is formula. But what is n minus k is k, which is right here. So this is equal to this. This is equal to this. So these two are actually equal. Okay. Okay. So what are the the use for binomials is that when you expand the factors for this exponent, okay. So let's say if you have 1 is equal to x plus y, x plus y squared is equal to x squared plus 2xy plus y squared, and x plus y cubed is equal to x cubed plus 3x squared y plus 3xy squared plus y cubed, etc., etc. And when you notice that the coefficient, when you pay attention to the coefficient, 1 and 1 is actually 1 0 and 1 1. 1 2 1 here is 2 0, 2 1, and 2 2. And 1 3 3 1 here is actually 3 0, 3 1, 3 2, and 3 3. So it turns out that the binomials corresponds to the coefficients in the expanded form of the um, uh, power of x plus y to the nth power. So this leads to the binomial theorem. Basically says when you expand this, right, so you would have a sum of n plus 1 items, n plus 1 terms. Right? Each term is represented by a coefficient, which is a binomial, times k power of x and n minus k power of y. Okay. So for example, when you write x plus y to the 5th power, right, so you know that when you expand it, you would have 6 terms, x to the 6th, x to the 5th times y, x 4y squared, x cubed y cubed, x squared y 4th, x y 5th, and y 6th. Oops, sorry. This is 5th power, so we should have only 6 terms. So it's this. Yeah. Right. So what is the coefficient for the x 5th? There should be 5 0. For x4 is 5 1. X third is 5 2. X squared is 5 3. This is 5 4. And last one is 5 5. Okay. 5 0 is equal to 1. 5 1 is 5. 5 2 is equals to 10. 5 3 is equal to 10 as well. And 5 4 is 5. And 5 5 is 1. So in general, this is x 5th plus 5x 4th y plus 10x cubed y squared plus 10x squared y cubed plus 5xy 4th plus y 5th as your expanded form. Okay. So this is when you have a addition inside the parentheses. Sometimes you will have subtraction Well, this is no difference than adding a minus sign. So that means one term would be having the base as a negative number. So when you expand it, is you know that there would be 7 um, um, terms when you add them. So specifically, you have 2x to the 6th power, and then 2x to the 5th power times minus y, and 2x to the 4th power minus y squared, 2x to the 3rd power minus y to the 3rd, 2x to the square times minus y to the 4th power, 2x to the 1st power minus y to the 5th power, and finally 2x to the 0 power, which is 1, times minus y to the 6th power. So as you can notice, when you simplify your minus y term, right, for the odd power, there was a minus sign, but for even power, the minus sign becomes positive sign. So in general, the sign should be alternating, meaning you have positive, right, negative, positive, negative, positive, negative, and then finally positive, the last term. Right? The sign is alternating, and the coefficient here is determined by the binomial. This is 6, 0. This is 6, 1. This is 6, 2. I just write it out here. 6, 3, 6, 4, 6, 5, and 6, 6. Okay. And when you do the calculation, 6, 0 is equal to 1. 6, 1 is equal to 6. 6, 2 is equal to 15. 6, 3, oh, this may be a little bit hard. This is 20. And 6, 4 is 15. 6, 5 is 6. And 6, 0 is 1. Right. A quick way to do that is use the identity here, right? Nk is equal to n minus k, which means that 6, 0 is equal to 6, 6, right? So you only have to do one calculation for both. Same thing as 6, 1 and 6, 5, 6, 2 and 6, 4, 6, 3, and you have to do the calculation once. Okay. So in total, after you get 6, 0, 6, 2, 6, 0, 6, 1, 6, 2, and 6, 3, right? The rest of 3 can be just, copy from the previous ones using the identity before. Okay. So let's do some exercise. Expand followings. X plus 1 to the 4th power and x minus y cubed to the 4th power. All right, let's go over the first one. The binomials for fourth power is 4, 0, 4, 1, 4, 2, and 4, 3, and 4, 4. Right, that is 1, 4, 6, 4, 1 for the coefficient. X to the fourth, x cubed y, 6x squared y squared, and then 4xy cubed, and finally 1 times 1 to the fourth. And same thing here, the coefficient would be 1, 4, 6, 4, 1. The first term is x to the fourth. The next one, a little bit tricky, is that you have x to the third power times minus y cubed. So this is plus y cubed. So minus y cubed to the first power. And here you have x to the square times minus y cubed to the second power. Here you have x times minus y cubed to the third power. Finally, you have no x power. So 1 times no x power times minus y cubed to the fourth power. Okay. So another use of binomials theorem is that you can find specific coefficient for a specific term. So for example, x plus y to the nth power is equal to k equals to 0 to n, and k x to the k, y to the n minus k. So for the kth power term of x, the coefficient is binomial nk. So equals to all the terms, and specifically for the kth term, kth power term, coefficient is this. Right? You know immediately that this is the coefficient for this term. So for example, for x plus y to the 22 power, right? And we want to find the coefficient for the 10th term. So for the 10th term, what is the power for x? So in this case, the first term start with 22 powers of x. And then the next term, you have 1 less power of x, but 1 more power of y. So that means in the 10th term, you should have 9 power of y and 22 minus 9 power of x. Okay. And what is the coefficient? Is 22 choose 9. Okay. So this is the 10th term. and that is the coefficient. Okay. And another one is that x plus 2y to the 16 power, right? When you expand it, what is the seventh term? Okay. Again, in the seventh term, you should have 6 power of 2y times 10 power of x, because 6 and 10 has to add up to 16. Okay. And what is the coefficient? That is, choose 6 from 16. Okay. And then you can use calculator to calculate 16 binomial 16/6. Right? The calculation will be a little bit daunting if you use by hand. Right? Or you can sometimes you'll be asked reversely. So x minus y to the 15 power, right? So what is the coefficient for the term x cubed y 12? Okay. So what is the coefficient? So you can notice you have 3 powers of x, right? Meaning you have so the binomial theorem reads okay. So if you have 3 powers of x, right, that means the coefficient is n choose 3. And in this case, the n is 15. So that is the total number of powers, right? So 15 choosing 3, which is 15 factorial divided by 12 factorial times 3 factorial, right? Again, 15 factorial divided by 12 factorial, all the previous 12 terms, right? 1, 2, 3, all the way to 12 is gone. So the only surviving term is 15, 14, and 13. So the numerator becomes 15 times 14 times 13 divided by 3 factorial, which is 6. Okay. So simplify this, you should get 5 times 7 times 13. 25 times 13, which is equal to 455. Okay. Sometimes they ask for the coefficient, sometimes they ask for the exponent of y. So for example, like x plus y to the 40th power. Right. So what is the exponent of y in the kth term. So in the kth term, that means you have one less k minus 1 power of y. This is 40 minus k minus 1, so that means 41 minus k. And the coefficient is n choose k minus 1. So that is the kth term. So the power of y is k minus 1. Okay. Right. The last thing to cover is evaluate big number of power by using binomials theorem. So for example, it's hard to evaluate this by hand, right? But what you can do here is use binomials theorem. So you can represent 102 by 100 plus 2. Right. So use binomials theorem, you know that you can expand it into 5 terms, right? And the coefficient corresponds to the binomials 4, 0, 4, 1, all the way to 4, 4, right? Which is 1, 4, 6, 4, 1. Right, so that is the coefficient. So this is 1 times 100 to the 4th power plus 4, 100 to the 3rd power times 2 to the 1st power, 6 times 100 square, 2 to the 3rd power, plus 4 times 100 times 2 to the 4th power, finally 1 times 2 to the 5th power. Wait, this makes sense. Well, this is square. This is cube. This is 4th. Sorry about that. This would be easier because you know 100 to the 4th power, right? So that's 10,000. 100 to the 3rd power, which is a million, right? Wait, hold on. 100 to the 4th power is 10 to the 8th power. This is 100 million, and 100 to the 3rd is 1 million. 100 to the square is 10,000, and 100 to the 1st power is 100. So it's equal to 10 to the 8th power plus 8 times 10 to the 6th power plus 24 times 10 to the 4th power plus 32 times 10 to the second power. And finally, you have only 2 to the fourth, which is 64 times 10 to the 0 power, which is 1. Right? And when you add them up, you have 264, 24, 8, and 10. Right, 64, that is 64. 32 times 10 square, 10 to the, 10 square, which is 3200. So it becomes 3264. And when you add 24 to the 10 to the fourth power, it becomes 24, 32, 64. And you can just add them up, one by one. So this is rather easier to do without a calculator. So exercise. Let's do 97 to the third power using binomials theorem. All right, let's go over this. So 97 can be represented by 100 minus 3. Right. So for cubic powers, the coefficient is 30, 31, 32, and 33. That is 1, 3, 3, 1. So you know that the coefficient is 3, 1, 3, 3, 1. Right? Because this is a subtraction, the sign goes alternatively. So 1 minus 3, positive 3, and minus 1. Okay, so let's start with positive powers. So 1 times 100 to the third power minus 3 times 100 to the square power times minus 3 to the first power. Right? And next one is plus 3 times 100 times minus 3 square. And finally, minus 1 times 100 to the 0 power, which is 0. Oh, Sorry. When you figure out a sign, you should have all positive. So this is 3 to the first power. Three square. This is minus 3 cube. So 100 to the third is 10 to the sixth power minus 3 to the first power is 3. 3 times 3 is 9. So 9 times 10 to the fourth power. 3 squared times 3, you should get 27 times 100 minus 2 to the 2 cube, which is 27. So the answer should be 27,000 minus 27. You should get 2673. Right? 10 to the sixth minus 9 times 10 to the fourth. You should get 91 times 10 to the fourth, which is 91,000. So this is your final answer. You can verify this by using your calculator. And you should get the exact same answers, which I did, and so should you. Okay. Any questions? All right. So again, review session on this Thursday, and then next Tuesday will be exam. Okay. Yeah, sure. Okay. So here's the deal. So after this class, when you move on to Cal 1, which is Math 150, if you don't have B minus or above from this course, you will need 140 concurrently with 150. So which means you have to take 140 and 150 at the same time. If you have B minus or above for this course, then you don't need 140, right? But if you don't have C or above for this course, then you won't be able to get to 150 unless you take this course again. And in terms of recitation, next week would be the last recitation. But the thing is, for the last week of recitation, there is no worksheets. Basically, it will be a kind of like a review session hosted by your recitation leader, and I'm not sure how he will structure the recitation for next week. But yeah.